Okay, because we're a little short on time because of the drill, I'm going to skip over number 1 and go straight to number 2. So while Athena was comparing the expressions, she was called out of the room. When her teammates needed help, they looked at her paper and saw the work shown below. Unfortunately, she'd forgotten to explain her simplification steps. So let's see if we can figure out what happened. So these are the original expressions. So our question is, as we move down to the next one, what has changed? So when we move from this first row to the next row, what has changed at this point? Quentin?
She took out the x squared because both of them had x squared, and it was there.
All right, so she removed an x squared from both the left and the right. And that's part of the idea of keeping this balanced. If you take something away from one of them, you should take the same thing away from the other one. All right, what has happened as we go from this step to this step on both sides? What have they done? Quentin?
Minus negative 2 is the same thing as plus 2. And on the other one, and then you would have a 4 plus 2x and a negative reason, so they just swapped it and put negative 4 and a negative 2x.
Okay, so they've rewritten the subtraction as adding the opposite, right? If you're subtracting a negative 2, that's the same thing as plus 2. And here you're subtracting 4 and subtracting the 2x. Now, what's happening up here? What would they be doing? They'd be flipping them. So they're flipping the parts in the negative region into the positive region. Then what's happened from here to the next step? Yes, Jill?
She just simplified the equation.
Yeah, we have simplified. And I'm going to go a step further and say simplified by grouping like terms. We have combined the x values and we've combined the constants. And then from here to the last step, what have we done? Yes, Sam?
They removed 2x from each side.
Yes. We removed a 2x from each side. And because 6 is greater than negative 5, the left side is greater. All right, let's go on to page 2. Do you have an extra or something? Okay. You can just ask me to get it rather than passing it around. Thank you. All right. So writing out an explanation like we did on number 2 is kind of a pain. Okay? What we would rather do is write it out symbolically and not have to write it out in words? You'd rather write it out in words?
Yeah.
So
That's just me.
mathematicians try to write as little as possible. So let's work on this. First of all, let's write exactly what we have. So on the left side, we've got 1 minus 3 minus, not minus 3x, just minus 3, minus 2x, minus, in the negative region, a negative x plus 3. And then here we've got 2 minus 3 in the positive region, minus an x minus 2 in the negative region. All right, so the first thing we're going to do is any simplifying we can do, we're going to do that. So 1 minus 3 is what? Negative 2. And we'll do the same thing over here. 2 minus 3 is? Negative 1. So we simplified by grouping any like terms that we could. Now we're going to flip all these that are in the negative region up into the positive region. So we'll have negative 2 minus 2x. And what are we going to have here? Plus x minus 3, exactly right. And then on this side, we'll have negative 1 and negative x plus 2. Because we're subtracting, we're going to add on the opposite. All right, now let's simplify both sides again. Negative 2x plus x is what? Just negative x. Negative 2 minus 3 is negative 5. Over here, we've got a negative x. And negative 1 plus 2 is 1. So then if we removed a negative x from both sides, we've got negative 5 compared to 1. So which side is greater? The right side. All right, let's try that on some more problems. We're going to determine which is greater, recording our steps as we go. If you can't tell which expression is greater, state not enough information. So, like Kiara and I were talking about, I'm going to start with the highest powered terms first. So negative x squared minus x squared plus 2x minus x squared plus 1 minus 1. On the right side, we've got x plus 3 minus 1 minus x squared plus 1. All right, on the left side, is there anything we can do in the positive region with the x squared, the minus x squared, and the 2x? I'm sorry, I heard lots of... Yes?
Okay.
Just in this region.
On the left,
Yes, just in the positive region.
you can eliminate the x squared plus negative x squared.
Yeah, because that's a zero pair, isn't it? So this is just going to be 2x minus, what about inside the parentheses? Yeah, the 1 and the negative 1 add out, so That's just going to be x squared. Simplifying first is always a good idea. Always, always. Question or? Yeah. All right, here in the positive region, the 3 minus 1 is 2. But that's all I can do. So simplify as much as you can. Then we're going to flip these up. So I'm going to have 2x minus x squared and x plus 2 minus x squared minus 1. Which side can I simplify? On the right side, we can simplify that. So here I've got 2x minus x squared. Here I've got x minus x squared plus 1 because it's positive 2 minus 1. Exactly right. What can I remove from both sides?
X squared.
Yeah, the negative x squared, yes. So I've got 2x and x plus 1. Do I know which one is bigger? No, it depends on how big x is. If x is 1, well, they're actually equal to each other. If x is 10, this is 20 and this is only 11, so the left side would be bigger. So it depends on the value of x. So this is a not enough information. All right, let's see what we can do with this one. Let's see, in the positive region, I have 1, 2, 3, 4, 5 x's and 2 negative unit tiles minus, got 3 x's plus 2 unit tiles in the negative region. In the positive region here, I've got 2x plus 3 and a minus 1 minus 2. Oh, you know what? I left out this 1, didn't I? Sorry about that. So I can do a little bit of simplifying there. The negative 2 plus 1 is what? Negative 1. And I can simplify this. 2x plus 3 minus 1 is 2x plus 2. So let's see, this is going to be 5x minus 1 minus 3x minus 2 and 2x plus 2 minus 2. Group the like terms now. 5x minus 3x is 2x. And negative 1 minus 2 is negative 3. And this is going to be 2x. Just 2x, right? So then if I remove the 2x from both sides, I've got negative 3 over here and I've got 0 over here. So which one is greater? Yeah, the right is greater. Okay, let's try simplifying both of these without any tiles. So over here, we usually don't have what's not in the parentheses next to each other, but I've got 5 minus 2, so that's 3. Minus 2y minus 4. And here, I've got negative y plus 4 minus 1 plus y. So group any things that are alike to start with. Then we'll flip the negative part, so that'll be 3 minus 2y plus 4. And negative y plus 4 minus 1 minus y. So here, yes?
So, like, when you take the negative out of the parentheses, you have to change the sign, right?
Right, what we're doing is we're taking those from the negative region and flipping them up to the positive region so they have the opposite sign. Yes?
On the other side with the y's.
The other side. Oh, we're going to get there. We're going to simplify both sides. On the left, it's negative 2y. On the right, plus 7. On the right, it's negative 2y plus 3. So if we got rid of the negative 2y's on both sides, we're comparing 7 and 3. Which one is greater? The one on the left. Let's see if we can get this one done. So let's look at this. What's the only simplifying we can do on the left? Yeah, the 9 minus 7. So I've got 3xy minus 4x plus 2.
What about the plus x?
Oh, sorry, I missed that. So if we group these two, then what should this be? Not negative 4x, but negative 3x. And on this side, there's no simplification we can do at first, but we'll go ahead and flip the stuff from the negative region into the positive region. And then group the like terms. So we've got 3xy minus 3x plus 2. These are the same. Okay, any questions about that? All right.